Nike Hercules guided missile system is a powerful component of the U.S. Army's air defense arsenal. The accuracy and destructive force of the weapon have been repeatedly demonstrated against high and low altitude targets. In its most familiar configuration, the Nike Hercules is emplaced on permanent sites in the vicinity of the nation's major industrial and population centers. These sites are divided into two areas: the battery control area with its controlled trailers and radars, and the launching area with the Hercules missiles and launchers. But Nike Hercules is not limited to such solidly constructed sites. It is mobile and can be rapidly deployed. In view of today's world military tensions, it is vital to have an air defense weapon with the capabilities of the Nike Hercules that can be moved on short notice to protect strategic targets anywhere in the free world. The equipment of a Nike Hercules firing battery in march order stretches out for a mile or more along the road. Normally, Nike Hercules battalions with their 4 firing batteries are assigned at the field army level or to major area defense commands. As this mobile unit moves out to the range near Fort Bliss, Texas, for a training exercise, we'll look at the equipment and observe a simulated firing mission. The firing battery is separated along both organizational and functional lines into 2 platoons. There is a fire control platoon and a launching platoon. The fire control platoon sets up its equipment in the battery control area, the launching platoon in the launching area. Selection and preparation of the emplacement site involves considerations of spacing and equipment location if best performance is to be achieved. Under combat conditions, of course, there would be additional requirements for camouflage and concealment. One of the prime considerations when locating the battery site is to make sure that radar coverage is not unnecessarily hindered by terrain features or built-up areas. Although the missile launchers are usually positioned ahead of the radars along the main target line, the Nike Hercules system can defend against attack from any point of the compass. Let's look at the battery control area. This is the nerve center of the battery, containing the radars, the computer, and the main operating consoles. The LOPAR, or Low Power Acquisition Radar Unit, detects incoming targets. The LOPAR may be used alone or in conjunction with other acquisition radars. For detecting targets at greater ranges and at altitudes of today's most advanced jet aircraft, a mobile high-PAR, or High Power Acquisition Radar, has been developed. Associated with the high-PAR are huge trailers in which are mounted the electronic elements required for its operation. The fire control platoon has 3 other radars besides the acquisition radars, which appear to be similar to each other, but have different functions. The target tracking radar tracks the target in azimuth, range, and elevation, while target ranging radar tracks the target in range only. The missile tracking radar tracks the missile and transmits to it the guidance commands generated by the computer. All of the tracking radar antennas and reflectors are housed within fabric radomes, which are supported by stiffening rods and inflated by air pressure. In a typical positioning of the radars, the tracking units are set up in a line with the LOPAR nearby. Another item of equipment in the battery control area is the antenna and mast group, which is used in aligning and checking the performance of the tracking radars. Battery fire control operations are centered in the Director Station Trailer. This is the command post of the Battery Control Officer, or BCO, who has communication facilities and control devices to help him direct the operations of his unit efficiently and effectively. On the early warning plotting board, targets are charted from information sent in from higher echelons of the air defense network. The main console contains the scope displays for the acquisition radars, plus a variety of controls and indicators. Above the console are horizontal and vertical plotting boards. Pens automatically trace the movements of missile and target during an engagement and indicate time and place of predicted intercept. The trailer also contains a communication switchboard and the system computer group. Located near the director station is another trailer which houses the tracking station. Within the trailer are the scopes, controls, and indicators for the 3 tracking radars, power supply units, and communication facilities. The tracking station trailer is usually positioned so that the radar operators can visually check through hatches the tracking radar antennas. Another trailer is equipped as a mobile electronic shop. Provided here are storage facilities for test equipment and spare parts, as well as workspace for maintenance and repair tasks. The Nike Hercules system requires a large amount of electrical power, and it takes a number of generators to supply this need. A standard generator is a 45 kilowatt, 400 cycle unit. The integrating of battery components requires many electrical cables for operation, control, and communication circuitry. The cable terminals are color-coded to facilitate the speedy link-up of connections. Junction boxes on the outside of trailers and equipment units display matching colors to prevent confusion. Cables connect equipment in the battery control area with that in the launching area. An uninterrupted line-of-sight relationship between the missile tracking radar and missile launchers is required. The launching area contains equipment for delivering the lethal punch of the Nike Hercules system. Major items here include the mobile launchers and associated equipment. 3 launchers are allocated to each of the 3 launching sections of the platoon. The launchers are set up with loading racks on either side, which provide for storage of a second missile and are an aid in moving the round onto the launcher. A launcher control indicator shows the status of the missile on the launcher and allows local control when it is being serviced or tested. In each section, there is a selector panel mounted in a small trailer which functions as an intermediate control point. From here, the firing panel operator can monitor and elevate the launchers in this section, designate the missile to be fired, and communicate with other elements of the battery. A trailer-mounted launching control station is the center of platoon operations. On a master console, the status of all loaded missiles in the battery is indicated. Controls are provided for selecting a section for firing a designated missile. In an emergency, the fire command can be originated from this panel. On the outside of the trailer is a mast which holds the flight simulator. This unit provides a beacon which the missile tracking radar locks on until a missile has been selected. It also simulates a missile for test purposes. Within the launching area complex is the assembly area where the non-explosive parts of the missile are unpackaged, assembled, and tested. Work done here involves the complete checkout of the missile's hydraulic system and electronic circuits. The missile body is transported from the area with equipment especially designed for the Nike Hercules system. Associated with the assembly area is the service area, strictly reserved for operations involving the explosive components of the missile and rocket motor cluster. Here, of course, safety procedures are matters of utmost importance. If the site is permanent or semi-permanent, protective revetments are constructed. It is at this location that the missile rocket motor is installed, an operation requiring the exercise of great skill and precision. With rocket motor cluster attached, the round is 39 feet long and weighs 10,000 pounds, equally divided between rocket motor cluster and missile. The missile in flight is maneuvered by the movement of 4 elevons. The elevons are attached to the trailing edges of the 4 main missile fins. The forward fins provide additional stability to the missile in flight. Components within the missile body include the guidance set, the warhead, the missile motor, and the hydraulic system. A general roundup of Nike Hercules hardware can barely hint at the complex functioning of the system. And it cannot adequately suggest the importance of the skill of the soldiers who man the weapon system. In this simulated combat situation, the target against which the battery will go into action is first detected on radar screens by the Army Air Defense, is then relayed to the battery director station. The operator on duty receives this information, alerts the other battery personnel by changing the operational status from white to blue, and turns on the siren. Reacting with customary speed that reflects the training of these men, all stations are quickly manned. Target information received from higher echelons is entered on the early warning plotting board. The BCO closely checks the reported geographical coordinates of the target, along with its direction, speed, and altitude. He can then point out to the acquisition radar operator where the target is most likely to show up on his scope. If the aircraft continues on its present course, it should approach the battery from the indicated direction. When the invader violates the territory monitored by the battery radar, it is picked up initially by the acquisition radar system. In the director station, the acquisition radar operator is alert and spots the target blip on his scope. If the target has not already been identified, the operator initiates procedures to establish it as friend or foe. Acquiring the target is the first phase of the engagement. This is done with the high PAR or the low PAR, which provides target, azimuth, and range data to the target tracking radar. The acquisition radar operator positions the azimuth line and range circle over the target video. He now designates the target to the operators in the tracking station. In the tracking station, the azimuth operator presses the acquire switch, transferring the target to the tracking radars automatically. The target tracking radar antenna points at the target. The target ranging radar operates in conjunction with the target tracking radar. The target tracking radar operators manually track the aircraft in azimuth, range, and elevation. When a good track has been established on the hostile pip in all three coordinates, the radar is locked on target. The target tracking and target ranging radars now automatically track the enemy aircraft and feed target position and range data to the computer in the director station. The missile tracking radar acquires the flight simulator on the launch control station while the operator checks out his radar and waits for a missile to be designated. Meanwhile, the launching crews have not been idle. Equipment already at an advanced alert status is subjected to final pre-firing checks. When the missile is ready, the launcher is raised. As each section brings its missiles to firing readiness, the information is made available to the launching control officer. At the launching control station, the LCO monitors the status of the missiles in the section and selects the one for firing on command of the BCO. After the missile has been designated, the missile tracking radar acquires the missile on the launcher. With this accomplished, the computer establishes a predicted intercept point. This information is sent to the missile as gyro preset data, constantly changing as the target position changes. At the director station, the BCO carefully observes and directs the required sequence of events preceding firing. On the horizontal plotting board, one pen traces the target's geographical position. The other indicates the predicted kill point. The vertical plotting board shows the altitude of the target and kill point, as well as the time remaining before intercept based on an immediate firing. When the target comes within range of the Nike Hercules system, the ready-to-fire signal lamp on the director station console lights. The firing command is not automatically transmitted, but depends on the decision of the BCO, who must bear in mind all aspects of the engagement and fire the missile at the optimum time. Separation of missile body and rocket motor cluster occurs. These are tense moments for all battery personnel. The weapon is functioning automatically now, and a successful kill depends on how well they have done their work. The automatic plotting boards now show the path of target and missile as they come together at dizzying speeds in the distant reaches of the sky. During this phase of the encounter, the computer is getting a steady flow of data regarding the location of both target and missile, and is generating steering orders designed to effect an intercept. The burst command is automatically transmitted to the missile at the critical point in time and space. An intercept spells success for this mission. When the Nike Hercules is used in a surface-to-surface role, the target position is fixed. Therefore, the acquisition and target range radars are not required. Target position information is set into the target tracking radar. This information is sent to the computer and used to guide the missile to a predetermined point above the target. The missile is directed to dive down on its target and deliver the knockout blow. Mobile employment of the Nike Hercules system involves attention to problems of maneuver and emplacement not encountered in the more permanent installations. The Nike Hercules mobile concept provides a greater flexibility of response to aggressor pressures throughout the world by making a powerful air defense weapon of proven reliability available to overseas commanders wherever it is needed.